Welcome to the video I've entitled A Much Too Quick Overview of Foundational Concepts in Science, structured around the issues of scientific observations, scientific facts, scientific hypotheses, scientific theories, and scientific laws. This video was written and produced and is presented by me, Andrew Chapman. Scientific observations, scientific facts, scientific hypotheses, scientific theories, and scientific laws are all essential concepts in science, but they are often misunderstood or confused with one another. In this video, we'll investigate and explain the differences between these terms and dispel any misunderstandings about their definitions and relations. Scientific observations are the first step in the scientific method. They are objective and measurable phenomena that scientists can observe either through direct or indirect means. For example, an astronomer might observe the behavior of stars and planets through a telescope, or a biologist might observe the behavior of cells under a microscope. Scientific observations are important because they provide the raw data that scientists use to generate hypotheses, theories, and understand laws. Scientific facts are the way things actually are in the domain of phenomena studied by science. There is a difference between scientific facts and what we think the scientific facts are, or what we take the scientific facts to be at any particular moment. While the scientific facts themselves don't change, what we think the scientific facts are can change. What we think the scientific facts are is based on information that has been confirmed through repeated observations and experiments. Scientific facts are objective and verifiable by multiple sources, and they represent a fundamental understanding of the natural world. Scientific hypotheses are tentative explanations for particular scientific observations or phenomena. They are based on available evidence, but they have not yet been confirmed through rigorous testing. Hypotheses are important because they provide a framework for scientists to design experiments and observations to test their validity. For example, a biologist might hypothesize that a particular gene is responsible for a certain trait in an organism and design experiments to test that hypothesis. Scientific theories, on the other hand, are large-scale explanations for phenomena in general and have been rigorously tested and confirmed through observations and experiments. They are the most comprehensive and well-established explanations for a particular phenomenon in science. Theories are supported by a large body of evidence, and they're used to make predictions about future observations or experiments. As you can see, the word theory in scientific theory is different from the word theory in everyday conversation. In everyday conversation, we sometimes mean that something is just a guess if it's a theory. Within science, a theory is well-tested, well-corroborated, and provides an explanation of some area of phenomena in general. For example, the theory of evolution by natural selection is a well-established scientific theory that explains the diversity of life on Earth. Scientific laws are mathematical descriptions of necessary regularities governing natural phenomena that have been repeatedly confirmed through observations and experiments. They describe a fundamental relationship between two or more variables, and they can be used to make predictions about future observations or experiments. For example, Newton's laws of motion describe the relationship between force, mass, and acceleration, and they can be used to predict the behavior of objects in motion. It is important to note that scientific observations, hypotheses, theories, and laws are not mutually exclusive categories. Rather, they represent a collection of facets of scientific understanding, with observations providing the raw data, hypotheses providing tentative explanations of particular phenomena, theories providing comprehensive explanations of general phenomena, and laws providing mathematical descriptions of necessary regularities governing natural phenomena. Additionally, scientific facts are not the same thing as scientific theories, as theories are explanations that incorporate and explain a wide range of the observed facts. It is also important to recognize that scientific hypotheses, theories, facts, and laws do not exist on a sort of epistemic continuum whereby the things we're least sure about are hypotheses and the things that we're most sure about are facts or laws. A number of introductory books, especially in the sciences, get this issue wrong. Whether we are sure or not about something is irrelevant to whether it's a hypothesis, a law, a fact, a theory. The amount of evidence we have for something doesn't make something graduate from, for example, a hypothesis to a theory, or a theory to a fact, or a fact to a law. Hypotheses, theories, facts, and laws are separate components of an overall understanding of the natural world from a scientific perspective. In conclusion, scientific observations, scientific facts, scientific hypotheses, scientific theories, and scientific laws are all essential concepts in science that serve different purposes. By understanding the differences between these, we can better appreciate the processes by which scientific understanding of the natural world is developed and refined. Thanks for watching this video, which I entitled A Much Too Quick Overview of Foundational Concepts in Science Structured Around the Issues of Scientific Observations, Scientific Facts, Scientific Hypotheses, Scientific Theories, and Scientific Laws. This video was written, produced, and presented by me, Andrew Chapman.